For hundreds of years, we thought we had the sun all figured out. We thought it had this nice, predictable rhythm. But then, it faltered. And scientists, they missed the mark, big time, leaving them with a massive mystery. So in this explainer, we're going to dive into the story of how we're finally learning to listen to the sun's stuttering heartbeat. So let's start with this idea. What if the sun isn't just a static, giant ball of fire just hanging out in space? What if it's more alive? A dynamic, pulsing entity with its own heartbeat, a kind of cosmic engine that drives everything we see. This very idea is at the center of one of the biggest puzzles in solar physics today. All right, so for the longest time, we really thought we had this rhythm down cold. I mean, it's a secret the sun's been broadcasting for as long as we've had the tools to watch it. And here's the basic beat. It's all about sunspots. Ever since the 1800s, we've known that the number of these dark spots on the sun's face goes up and down in a cycle that lasts about 11 years. We've been counting them since 1755. It's the most obvious pulse the sun has, and we call it the Schwabe cycle. Okay, so once we had that main rhythm, scientists started gathering other clues. They found all these different solar phenomena that seemed to be, dancing to the exact same beat. These became the go-to signs for tracking what the sun was up to. But here's where it gets interesting. There's a rhythm underneath the rhythm. That 11-year sunspot cycle, it's really just a symptom of something deeper, a 22-year magnetic cycle. See, every 11 years, the sun's entire magnetic field just flips. North becomes south, south becomes north. So for a full reset, a complete magnetic cycle, you need 2 of those sunspot cycles. And what's wild is that it wasn't just sunspots. Everything seemed to be marching in lockstep to this 11-year drumbeat. Huge solar flares, the sun's total brightness, even radio waves it emits. They were all in sync. Everything seems so clear, so predictable. What could possibly go wrong? Well, that very clear picture was about to get really, really blurry. Because when it was time to predict the sun's next move, the entire scientific community got it spectacularly wrong. This physicist, Robert Layton, he basically saw this coming way back in 1969. He warned everybody that just watching all these clues was pretty useless unless we understood the actual physics driving them. He was saying, hey, just because 2 things happen at the same time doesn't mean you understand what's going on. And boy, was he right. And this chart right here, this is the scene of the crime. For solar cycle 24, starting back in 2008, look at the predictions. Most scientists were calling for a pretty average cycle, maybe 120 sunspots at its peak. Some thought it would be even stronger, but the actual number, it barely squeaked past 80. It was one of the weakest cycles in a century. The predictions weren't just off, they were in a different ballpark. Now, this wasn't just a simple miss. This was a huge red flag. It meant the fundamental relationships that scientists had trusted for decades were literally breaking down right before their eyes. The case of the predictable sun, it had just gone ice cold. So this massive failure forced a huge shift. Scientists had to stop chasing the clues and start hunting for the culprit itself, the sun's hidden magnetic engine. Just like Layton had warned all those years ago, the core of the problem was that scientists were mistaking the symptom for the cause. They were tracking things like radio waves as if they were the sun's activity, not just a byproduct of it. It's like they were expertly measuring a shadow on the wall, and then suddenly the object casting it completely changed shape. And you can see the moment the shadow changed right here in the data. For almost 50 years, the sunspot number and the radio flux were practically joined at the hip. They tracked each other perfectly. But then, right around the mid-90s, that rock-solid relationship just fell apart. The 2 clues started telling completely different stories. So there's a term for this divergence, the sunspot formation fraction. It's basically the ratio of sunspots you actually see versus what the radio signals predicted you'd see. And after 1995, that ratio just kept dropping. This wasn't just a math quirk, it pointed to a real physical change. The magnetic fields inside the sunspots themselves were getting weaker. All the evidence was now pointing to one prime suspect, the solar dynamo. This isn't something you can see. It's the deep, complex, and frankly mysterious engine room of the sun that generates its entire magnetic field. And something inside that engine was misfiring. But how do you possibly look inside a star? Well,
The answer came from a totally revolutionary new approach. It was time to stop just looking at the sun and start listening to it.
And this is where a field called helioseismology comes in. It's as cool as it sounds. The sun is constantly humming with sound waves that ripple across its surface. By analyzing those vibrations, scientists can actually map out its interior. It is literally like giving the sun an ultrasound. For the first time ever, we could finally peek under the hood. And what they found was absolutely stunning. By tracking the frequencies of these sound waves, they noticed something weird had started all the way back in 1996. The lowest frequency waves, the really deep bass notes of the sun, had started to change their tune. It was a subtle warning from deep within the star, hinting that a key magnetic layer was actually getting thinner. Now think about that. Years before the predictions failed so badly, the sun itself was broadcasting that something was wrong. Its engine was changing, and for the first time in human history, we finally had the technology to hear it. So, where does all this leave us? Well, this is definitely not a case-closed situation. It's more like the beginning of a brand new investigation. Only this time, we're armed with much, much better tools. You see, in the end, the great prediction failure wasn't really a failure at all. It was a breakthrough. It was the giant wake-up call that forced science to throw out the easy correlations and start doing the really hard but really important work of understanding the physical engine that actually drives our star. So, we've learned how to listen to the sun's interior, but we're really just starting to learn its language. The last cycle was a quiet little stutter, a murmur that warned us we didn't know nearly as much as we thought. The real question, the big mystery now, is as the sun's engine keeps changing, what will its next cycle scream?